We are continuing our section 1.2 notes. This is where the sound cut off, or about where the sound cut off. So I'm just creating another video to extend the rest of the notes. So now what we're going to talk about is multiplying fractions. And when we're multiplying fractions, if we have A over B times C over D, we simply go ahead and multiply the numerator times the numerator and the denominator times the denominator. So we would have whatever A times C is over whatever B times D is. From there, we would simplify and reduce it just like we learned how to do in the previous example. So looking at example 3, it's asking us to multiply the fractions. So you have a few different ways you can do this. One way is to multiply straight across and then go ahead and simplify whatever this resulting fraction is. Now, that's perfectly fine to do. However, if the numbers get really, really large, this can be very difficult to simplify. So a second option is instead of multiply then simplify, you can simplify and then multiply. So I'll show you both ways of doing this in each A and B. So for A, we go ahead and we look at each individual fraction and check, is the fraction simplified? So is 4/5 simplified? Yes. Is 6/7 simplified? Yes. And then we can also cross simplify as well, or cross reduce. We can ask, if we put a fraction 4 over 7, is that completely simplified? Yes, it is. Also, 6 over 5, is that completely simplified? Yes. So what that tells us by answering all of those seemingly repetitive questions, it tells us that when we multiply 4 times 6 and we put it over 5 times 7, it tells us that that answer, that product, is going to be simplified as well. 4 times 6 gives us 24, and 5 times 7 gives us 35. So if we want to check if we can simplify it, we want to look at all of our factors of 24. So I'm just going to do this on the side. 24, I know I can get 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then we can do the same thing for 35. Let's see, 1 times 35 gives us 35. Not 3, but 5 and 7. And if you look at each of the individual numbers, the only factor that they have in common is 1. Everything else, there's no 5 or 7 or 35 here. So that means that 24 over 35 is completely reduced. Excuse me. So next we have 3 times 5/9. Now the issue here is that we don't have a fraction times a fraction, we have a whole number times a fraction. So what we can do is we can just put 3 over 1. Voila, we have a fraction. Excuse me. Now we look at our individual fractions. 3 over 1. Oh, actually, you know what? Let's go ahead and multiply it first and then reduce, and then see how it is the other way. So when we multiply it, 3 times 5 gives us 15. 1 times 9 gives us 9. We can divide each of these by 3, and we end up with 5 over 3. Now, that wasn't so bad because the numbers weren't very large, but again, when you get really, really large numbers, like that example 2b, where it was 495 over 735, that's pretty difficult to reduce. It takes more work, I should say, to reduce. So another option is to reduce first. So we start off with our original fraction, 3 over 1 times 5 over 9. Is 3 over 1 completely simplified? Yes, it is. Is 5 over 9 completely simplified? Yes, it is. And then we cross. 3 over 9. Is that completely simplified? No, we could divide each by 3. 3 divided by 3 is 1. And 9 divided by 3 is 3. So we've reduced that, cross-reduced that. Then we look at 5 over 1. Is that completely simplified? Yes, it is. So now we can just multiply straight across. 1 times 5 gives us our 5, and 1 times 3 gives us our 3. Same exact answer, sort of different ways of doing it. Now, along with multiplying fractions comes dividing fractions. When we are dividing fractions, let's grab a pen that I like here. When we're dividing fractions, for instance, A over B divided by C over D, we can actually change it into a multiplication problem. Dividing one fraction by another fraction is the same as multiplying the first by the reciprocal of the second. So that's also known as like copy dot flip. So we copy the first fraction, A over B. We, instead of having division, we have multiplication, so that's where our dot comes in. And then we flip or take the reciprocal of the second fraction. A reciprocal is just taking a fraction, C and D, and switching the numerator and the denominator. So that becomes D over C. And then from what we learned about multiplying fractions, we would just multiply straight across AD over BC. Let's go ahead and try some problems. We have 1/3 divided by 3/5. Now, when we were talking about multiplying earlier, we would check is each fraction reduced, and then we would cross-reduce as well. We can't check that until we change it into a multiplication problem. So that's our first step, changing it into that multiplication problem. So here we have 1/3 divided by 3/5. I'm going to go ahead and copy the 1/3, put a dot in the middle for the multiplication, and then we're going to flip. So the reciprocal of 3 over 5 is 5 over 3. Now that we've changed it into a multiplication problem, it becomes more practice for multiplying fractions. 1/3 is completely simplified, 5/3 is completely simplified, and then 1 over 3 is completely simplified again, 5 over 3 is completely simplified again. So we multiply straight across. 5 over 9 being our completely simplified answer. Excuse me. Let's see if we can zoom in just a little more. Okay, that's better. Part B, we sort of have that same issue where we have a whole number here, 5, so we're just going to put our 5 over 1. And we want to change this into a multiplication problem. So we keep our 5 over 1, we copy, dot, and then we flip. Our 10 over 25 becomes 25 over 10. Again, that's called the reciprocal. Now, is 5 over 1 completely simplified? Yes, it is. Is 25 over 10 completely simplified? No, it's not. We can divide each of these numbers, 25 and 10, by 5. So that reduces to become 5 over 2. I'm just going to go ahead and rewrite it so we can see it without too much mess. Now that we've simplified both of the individual fractions, we would cross simplify. 5 over 2, yes, that's simplified. 5 over 1, yes, that's simplified. And we would go ahead and multiply straight across. 5 times 5 is 25, and 1 times 2 is 2. Completely simplified. Okay, next after multiplying and dividing fractions, we want to know how to add and subtract fractions. Now, when we're multiplying and dividing fractions, when we multiply straight across, numerator times numerator, denominator times denominator. When we're dividing, we change it into a multiplication problem. So then, again, we just change it into multiplication, then multiply straight across. But when we are adding and subtracting fractions, the one thing that you have to have that is non-negotiable is a common denominator. So that would be something like A over C plus B over C. Once you have that common denominator, then you can keep that common denominator of c and add your numerators. Or likewise, if you're dealing with subtraction, a over c minus b over c, you can keep that common denominator and then just subtract your numerators, whatever's appropriate. The key thing is having that common denominator. So let's try to, go ahead and add and subtract these fractions. First, do we have a common denominator? Yes, it's 13. So I'm going to keep that common denominator of 13, and then I'm going to go ahead and add my numerators together. 5 plus 12. 5 plus 12 is 17. So we have 17 over 13. And can we reduce 17 over 13 at all? No, that is completely simplified. Both of those numbers are prime numbers, so 17/13 is our final answer. Then part B, do we have a common denominator? Yes, we do. It's 8. So we keep that common denominator, and we take 11 minus 5. That leaves us with 6 over 8. And can we reduce this or simplify this? Yes, we can. We can divide each of these by 2 to give us 3 over 4. Is that completely simplified? Yes, it is. So that's our final answer. Now, what happens when your initial fractions do not already have common denominators? They don't start having common denominators. Well, what you have to do is you have to find a common denominator. Now, one way to find a common denominator is just to take the two different denominators and multiply them by each other. That gives you a common denominator, but oftentimes that'll give you a common denominator that's much larger than it has to be. So we have this thing called the least common denominator. So the least common denominator is the smallest number that's divisible by every denominator. Or in other words, the least common factor between the two denominator values. So if we're looking at, let's say, two denominators, one, 7, I'm trying to think of something that works. 7/4, and we're trying to add that to 5/6. One option is to multiply the two denominators by each other, 4 and 6. So we multiply our first fraction by 6, our second fraction by 4, and what that does is it gives us, let's see here, 42 over 24 plus 20 over 24. Now we have common denominators. When we add it together, we get 62 over 24, and then we need to go ahead and reduce that. And my numbers are a little large. I automatically see that they're both even, so I could divide them by 2. So that gives me 31 over 12, and that's completely reduced. Now, as a second option, though, is the least common denominator here. So this is just a common denominator. So let's look at our LCD. We have, again, 7/4 plus 5/6. Excuse me. We have a couple steps in order to find this. Let's see if I can have it down. Oh, I do have it down there. Okay. Whoops. So our first step is to find the prime factorization for each denominator. So again, I'm just going to write this down here. 7/4 plus 5/6. So one denominator is 4, the other denominator is 6. So we're going to go ahead and prime factorize each of those. Okay, that was easy, right? They're small numbers. And again, you might not necessarily need to do it for small numbers, but this just gives you an idea of how you would do it for larger numbers. So we have 4, which is 2 times 2, and 6, which is 2 times 3. That's step number 1. Step number 2, list each factor that appears in one or more of the factorizations. So in other words, we look at this and we see, hey, 2 appears in both of them. So I'm going to list that as part of our LCD, 2. If a factor is repeated in any factorizations, list this factor the maximum number of times that it's repeated. So we know that the 2 happens. We also have another 2 in here. And then we have our 3 that's left over as well. And when we multiply all that together, we get a least common denominator of 12, which, looking back at that other example, I have to flip my paper. Right, we ended up reducing it to 31 over 12. So it says the product of this list is the list of factors, is the LCD. So that's going to be our LCD. Let's try an actual example with this without me having to flip my paper a bazillion times. So we want to add these together. We have a denominator of 6 and 4. And when we have that denominator of 6 and 4, our first step is to find the prime factorization for each denominator. Oh, I have more room. I'll use this. So the prime factorization for 6 we just did 2. Oh, hey, we just did this a problem exactly like this. 2 times 3. 4, we have 2 times 2. So the way the textbook does it is it says, okay, these are in common, so I'm going to bring this down as part of my LCD, 2. And then we bring down each factor individually, times 2, and then we multiply by 3 to give us an LCD of 12. Now, the issue is, okay, looking at each prime factorization, what is missing, or what do we need in order to get the factors in our LCD? So here, for 6, we have a 2 and a 3. Here's a 2 and a 3. And we're missing a 2. So that means in order to make 6 into 12, we need to multiply it by that missing 2. Then when we look at 4, our factors of 4 are 2 and 2. So here it is, 2 and 2. What are we missing from from our prime factorization? We're missing a 3. So that means we need to multiply the 4 by 3. Now we can rewrite the fractions having common denominators. 10 over 12 plus 9 over 12. Since they have common denominators, we keep that common denominator and combine the numerators to give us a final answer, which is completely simplified, of 19 over 12. Now the same thing works even when you have 3 different denominators. You can still do the same thing. So 4, 2, and 10. I know that I'm going to do it over here. 2 is literally just 2. 4 have factors 2 times 2. And 10 has factors 2 times 5. So in order to find our LCD, we look at this and say, do 2 of them or all of them have something in common? Yes, they all have a single 2 in common. So I'm going to bring that down. Is there anything else in common between 2 of them? No. So then we just bring each factor down individually. Times by 5. And here we bring it down 2. When we multiply all of that together, we get our LCD, which in this case is 20. So now we want to make each of these fractions have that least common denominator. If I look at the factors of 4 here, I have a 2 and a 2. So when I go down to my LCD, here's my 2 and here's my 2. I'm missing a 5 from that factorization. So I need to multiply the first fraction by 5. Then a denominator of 2. Here it is right there. It only has one factor, 2. It's that one there. We're missing 5 times 2, which is 10. So we need to multiply that by 10. And the last one, 10, we have a 2 and a 5 already. 2 and a 5. We're missing another 2. Rewrite this, having those common denominators. 5 times 1 is 5 over 20 plus 10 over 20 minus 14 over 20. Common denominators are the same, so we work with our numerators. 5 plus 10 minus 14. 5 plus 10 is 15. 15 minus 14 is 1. And we have 1/20. If we had just multiplied all of the denominators by each other, we would have ended up having 80 as our least common denominator, which would have made us need to simplify whatever we got down here. So using the least common denominator is the most efficient way to do this. Example 7 deals with carpentry. I know you folks asked about this in class, but we'll just kind of go over it again. Maybe I can explain it better this time. We'll see. I'll try not to confuse you. So a board measures 35 3/4 inches and needs to be cut into 4 equal parts. It says find the length of each piece. So we have 35 3/4 of an inch. If it needs to be cut into 4 equal parts, then we need to take the total length and divide it by 4. Now the way this number is written with the 35 wholes and then 3/4 as your fraction, this is called a mixed number, and it's almost like saying 35 plus 3/4. This is not necessarily, a mixed number is not necessarily the easiest way to work with, to do operations on fractions. An improper fraction is. So in order to do that, we take our 35 and we multiply it by 4, and then whatever we get there, we add 3 to it. So if I could find a calculator here, I'm going to take this. If you can see it, hopefully there's no glare. Oops. So 35 times 4, and then I'm going to add 3. So 143 over 4 is going to be our fraction as an improper fraction. And again, because we have a whole number 4, we're going to write it as a fraction, 4 over 1. And how do we work with dividing fractions? Well, copy dot flip. Copy the first, 143 over 4, dot, change the division to multiplication, and then we flip to become 1/4. Now, check your reduction. Everything's fine, and we multiply straight across. 143 over 16. But if you take this measurement to your carpenter or your friend who has a table saw and say, hey, I need this board cut into 143/16 inches sections, they're going to look at you and they're going to give you a strange look, and they won't want to do it for you because that's not completely simplified. You have to make it understandable. In carpentry, 35 3/4, a mixed number is what's appropriate. So we want to change this back into a mixed number. Now there's a couple ways to do it. I know I explained it in class. One way to do it is using your calculator. Figure out what is the whole. So if we take 143 and we divide it by 16, we get 8 whole pieces. So we know that this is going to be 8 and something over 16. So you want to see, well, what is 8 wholes as something over 16? So we take our whole number, we multiply it by that denominator, that gives us 128. And what's the difference between 143 and 128? That gives us 15. Now, a second way to do it with a calculator is, we kind of go back up to here, 143 divided by 16, we get 8 point blah, 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 right? 8 point something. So that means, again, it's going to be 8 wholes and something. But then what you can do is you're really just needing to convert 0.9375 into a fraction. We learned how to do this in class. One way is to use your place value. 9375 tenths, hundredths, thousandths, 10 thousandths place. So we can take, let's get up there, 9,375 over 10,000, and we could reduce that to get a fraction. That's going to be a little cumbersome, so we can actually do sort of this in our calculator. We do that by saying, okay, well, I'm going to take away this whole number because I know it already belongs here in the mixed number. So I'm just going to subtract 8 to get rid of it, and I end up with just the decimal 0.9375. I'm going to take that now and multiply that by 16 to figure out what's the whole value of it, which gives us back our 15, which is what we had right up there. So either way, you're going to ask your friend, or you're going to cut lengths that are 8 and 15/16 inches long. Inches. Whew. So, whoops. Here is our try it problems. Here are our try it problems. I'm going to go ahead and zoom in a little more so you can have those. And you can go ahead and pause the tape. Tape. Oh boy. We can go ahead and pause the video, and we'll come back and do these together, and you can check your answers.